Morning, everyone. This is going to be a panel, quite a large panel, that has been hyped up by Todd yesterday and some other folks as we are talking about the plethora of test harnesses and benchmarking frameworks that are available to us here in HPSF and some of the goals that we have in the benchmarking working group. We figured it would be nice to have a diversity of different opinions and voices from a variety of different HPC centers and HPSF member organizations to have a chat about portable and reproducible benchmarks. Many of us have benchmarks throughout a variety of different life cycles, and we wanted to come together at HPSFCon and start a conversation that hopefully will continue and be fruitful for quite some time. So first I want to introduce the benchmarking working group, of which Jayesh and Olga are the co-chairs. And we have a whole charter on the HPSF website, which is probably a little bit too long to repeat here. But these are just some quick bullets of some of our goals. The main focus actually is that we really want to integrate with other HPSF working groups and HPSF projects to make sure that we are doing performance debugging and benchmarking effectively. Performance debugging is obviously a challenge, not only from a system software and hardware perspective when we procure hardware from vendors, but it's also a challenge for those of us implementing things like portability layers, schedulers, launchers, and all of our HPSF projects that we have. So some of our goals are to deduplicate effort. There has been a large amount of duplicated effort in this field, so we'll be getting into that in the panel. And we want to, increase benchmark portability and reproducibility. And I think this is a theme that has arisen organically as we want to do testing between clusters and between centers to make sure that we are able to compare apples to apples when it comes to performance debugging across a variety of systems and centers. And then, what's exciting that's coming out, of course, as I said, we want to align our benchmark development with our HPSF member projects, but we also want to really be interested in integrating with, in particular, continuous benchmarking, which would involve CI, or continuous integration working group. How do we federate CI? How do we make it so that if you think, maybe you even have a vendor that wants to run your benchmark in a reproducible manner on their own cluster, but they don't necessarily want to share just how bad their performance is in the first generation of their product. So they might, want to run things on their own without necessarily upstreaming everything they're doing. And so federation of CI is an important topic to us. And then the binaries working group is particularly interesting as we talk about various emerging target architectures. We want to be able to compare as close as we can as we have, a variety of new architectures coming online. So I've just outlined some needs here, and there's a lot more that we need out of our benchmarks, but this is just a few quick things that we do, and just to get folks thinking about sort of where we're going with benchmarking. Of course, we care about vendor simulation and co-design. In particular, of course, we all have compute kernels that we run. We have various workloads that are particularly important to us at all of our centers. We need to make sure those are represented in a benchmark suite that can be quickly and easily deployed by vendors on a variety of different hardware and system software platforms. And then one of the things that doesn't always come up is system burn-in. Of course, the phase, usually manufacturers will take care of this for high-performance computers, but it's important for us to be able to handle this as well. We do a fair amount of burn-in at Livermore in particular, where we may want to run micro benchmarks on memory, network, I/O, or CPUs or accelerators. Sometimes we're stressing the power architecture, the cooling architecture. We're trying to get as much, we're trying to break things before we find out in production. So burn-in is important on any given system. We want to level out power spikes and get things tested before they become an issue. And then of course we have what I'm calling system integration. Some folks may call this acceptance. I kind of consider acceptance a dirty word because we want to have more of a partnership, consistently with vendors or whoever provides our compute hardware to make sure that we're always integrating with our center. Hardware changes rapidly, but so do workloads. And so what might have been an important workload 5 years ago or whenever a contract was originally written might not be as important today, or in the case of AI, we've seen a lot of workloads that have emerged, and people will say, hey, we really want to benchmark this, and so we want to think of this as a continuous partnership with HPC vendors. And then we have a variety of things we want to integrate, obviously portability layers and resource management libraries like Umpire, Cocos, et cetera. A lot of the work here in HPSF is very important to us. It's excellent to be able to let vendors target that, get great performance at those layers, and then allow applications to use that. And then, of course, we have our proxy and mini applications as well, along with micro benchmarks that we'll do at this stage. And then system maintenance, every time we patch a system or update libraries, we want to make sure that we're testing to make sure we're not introducing any performance regressions in the system software stack. I'm just throwing out some of the many simulators, test harnesses, frameworks, et cetera, that we have available to us. For simulators, of course, one of the popular ones is Structural Simulation Toolkit. One of the goals that I would love to pursue is to see more vendors using this, because in the past it's been a bit of a challenge to get certain vendors to do full, the type of high fidelity simulations it's capable of. And then just burn-in tools, empirical roofline model doesn't get quite a lot of attention. A lot of us just run linpack until nodes crash. That's at least what we do a lot of at Livermore. Sometimes we'll run, repeated MPI all reduces until we, break something in the network. And then we have our test harnesses and benchmarking frameworks, of which there are many, and there's always more. We want to probably talk about why we keep doing this to ourselves as far as inventing more and more test harnesses. I don't think, I think people are approaching this in good faith. I think what happens is, so we have Reframe, Pavilion 2, Ramble, Benchmark, Jube, Canary, just to name a few of these. There are more, the thing is, they're all good, right? What I think happens is people start using somebody else's benchmarking framework, and then they say, oh, it does 90% of what I need to do, but it's also really complex, and so I want to add that 10% of functionality. And then they look at it and go, but I really don't care about maybe a bunch of other things it does do. I might as well implement my own framework. Then they start to implement their own framework, and then they realize, oh, I actually care about all of these other things. And so then the framework gets itself, much more complex. And so there's a real challenge for us of managing complexity, right? If you just think about, I want to test different hardware architectures with different compilers and different MPIs, and then different applications, and then different benchmarks, you suddenly get into this combinatorial explosion of different ways to run things. And then even with MPIs, do you want to do partition communicators? Do you want to test some of the corner cases that your users have handed to you? Some frameworks can do it, some can't. We have different schedulers and launchers, and so the complexity really gets almost out of control. And then we have results, storage, and analysis. This is a common issue for those of us developing these frameworks. How do you store results? What do they mean? How do you remember how they were run? Are we making assumptions about system software? And so we, oftentimes will assume that other centers run the same way as we do, or assume that a vendor runs the same software stack. That might not always be a good assumption, and sometimes even tuning variables. And so, environment variables and things like that can be changed all the time as well. And then, we want to allow testing the absolute latest software while still maintaining reproducibility and portability. And this is a challenge because with beta software or alpha software that you're given at the system software layer, this can be a big issue for maintaining reproducibility and portability, because not everybody has the same alpha software, and that software might have completely different tuning parameters for different users as well. So anyway, I'll start we're going to self-introduce the panel, because there's a lot of us here, so I don't want to introduce people twice, but we have an excellent panel who we're all going to be discussing this stuff, and I'm trying to get a really good representation between various different institutions, very different backgrounds, different continents, and so we're going to go through and introduce everyone. And so first we'll start with Tuomas.
Okay. Hello? Oh, okay. Hi, so my name is Tuomas Koskela. I'm a research software engineer in University College London in the Advanced Research Computing Center. And I work on the software side. My main job is supporting researchers who do computational software using HPC. I'm also involved in various UK national HPC strategy things, which sort of brought me into thinking about portable benchmarking. So we try to sort of push for good software development practices, sustainable software, and we try to think about how to bring this into benchmarking as well. So up until last year in the UK, we had a program called Excalibur, which was sort of inspired a lot by the ECP program, where we deployed a lot of hardware test beds, and we needed tools for deploying benchmarks on those. And I led a project to develop some tools because I didn't know better at the time. And we used SPAC and Reframe and built this thing we called Excalibur tests, which then led into a project that's ongoing called UKRI Bench, which is a project to sort of develop a living suite of procurement benchmarks. And the idea is to sort of have a suite of benchmarks where sites can pick the benchmarks they care about and deploy and run them, and vendors can sort of have visibility of what are the benchmarks the research community cares about and sort of tune their products before going into procurement. So I think like in the Excalibur project, we sort of wanted to give something to everyone. We wanted to like serve procurements. We wanted to serve research groups who develop software and want to monitor their performance regression. And we wanted to provide something for system administrators to monitor how the systems are behaving. I think maybe something I would like to discuss is sort of like how to drive adoption of these tools. I have a lot of conversations with people. The feedback I get is, this is excellent, and then nothing happens. And people feel like this is too complex and too brittle and everything breaks, and then they go back to what they have always done. So how can we sort of make this more user-friendly would be a good, interesting topic for me.
Thanks.
Thank you.
Next up we have Adam.
Hi, my name is Adam Lavely. I'm a user environment architect at NERSC. I primarily work on programming environments and containers. And at NERSC, we use Reframe for most of our benchmarking. But I would like to point out that we use this primarily looking at what happens when we change our underlying system software. So we have a suite of Reframe tests that are out there. A lot of these are things that are built around functionality that we want to ensure works, and then a lot of these are tests that or things that broke in the past and bit us, and so we want to make sure that it doesn't happen again. I also do quite a bit of benchmarking, looking at bare metal versus containerized performance for various applications. And I'm also working, so the HPSF benchmarking group got an allocation on Perlmutter this year, and so we're working to start that up. I need to do some work to get some test runners going, but that's going to be something that we'll be working on together as a group, and then we'll also be looking to talk with some of the other groups to make sure that we're doing things that's meaningful for the HPSF as a whole.
Okay, thank you. And next up we have Luke.
Hey everyone, so I'm Luc Berger-Vergiat at Sandia National Lab. I primarily work on both Trulinos and Cocos. Both of them are distributed in single node libraries that provide foundational software level for application. So think of linear algebra, optimization, solvers, etc. So I'm as part of these two libraries and work, we are very interested in the performance that we see across multiple platforms. Cocos itself has on its first main website page performance portable, and in order to be able to back up that claim, benchmarking is extremely important. For us, this is also the way to convince and gain trust from our users that things are not going to be regressing unexpectedly from release to release. And so when I think about benchmarking, I think of it in terms of, I guess, three main axes. One is really the getting on a system and doing some data gathering. A second step would be data post-processing once you're done running your benchmarking tools, etc. And eventually, you kind of want to think about hosting and how you share these data. And for benchmarking versus performance monitoring, it might take different shapes, but I think it'd be interesting if some of these discussions happen during the panel. And so, thank you.
Thanks. And next we have Engin.
Thank you. My name is Engin Kayraklioglu. I'm a member of the Chapel team at HPE. I've been with the Chapel project for 14 years. Half of it is just as a community member because it's an open source project, and last 7 years is more full-time, starting at Cray and then HPE. So at our team, we have two main purposes of benchmarking. One is more manual, kind of comparing Chapel against other technologies to see where we are lacking, and where we can improve. And the other one is to avoid performance regressions, which is more about like CI and nightly testing kind of a benchmarking. In terms of infrastructure that we have, it is something that has grown organically over 2 decades maybe, that is very bespoke for our needs. So it's kind of, as I said, organic. It's sometimes gnarly, it's sometimes really hard to maintain, sometimes it's really easy to extend. So it's really, it's kind of a beast. But at the same time, whenever we think about changing our infrastructure and using something more general purpose, there's always hard to justify the effort to change our infrastructure as opposed to working on a feature of the language. So that's a challenge that we face. And in terms of the biggest wish that we have, or I have, is just a big suite of benchmarks that are implemented in 15 different programming models that has like a complete table so that we can plug the Chapel versions in and compare against 15 different programming models. So having that in our community, I think, would be a big benefit for the Chapel project from my perspective. Thanks.
All right, thank you. And next we have Jayesh online. Jayesh, can you hear us?
Yes, I can hear you.
Okay, great.
Thank you. So yeah, I work at JSC nowadays, mostly in benchmarking and workflows. I gave a talk yesterday on XRCP, of which I was the primary developer, but now we have some more people. And we did this to support the early access program initially at Jupyter, but then also other things like the Jupyter Benchmark Suite. I'm interested in this mostly a lot because of similar points to what Nathan said, where we want to see how we can unify a lot of tools in a framework, or reduce the problem of too many different approaches in a way. And my talking points are in relation to that. So benchmarking definitions, benchmarking workflows, because at the end, I feel that benchmarks are workflows themselves. And especially for workflows, then I become interested in CI, because then that's how you can also try to get the applications interested in benchmarks if they can benefit from it directly on their development processes. And when you put into the CI, you have to deal with problems of not taking too many resources, because CI can be difficult to control sometimes. And then apart from this, recently I started also looking into topics like system benchmarking, where we want to essentially benchmark the full system with different workloads and utilization to see how it manages the power and other things. So that's it. Thanks.
Okay, great. Thanks, Jayesh. And finally, representing Livermore, Stephanie and I.
Hi, I'm Stephanie Brink. I have an expertise in HPC performance analysis and work with the larger team that develops the kind of performance analysis toolkit that includes Caliper, Thicket, and Hatchet. And along with Nate here, who works on our benchmarking fabrics and communication libraries, we kind of put together some of our site's benchmarking goals. We're really interested in rapid system software testing and iteration. So we want to be able to run our full suite of benchmarks that we're interested in as we, update software, as we substitute in one MPI library for another. Basically, as we're changing that underlying software stack, we want to be able to run our full suite to understand how did the performance change, did we have regressions. Something else that we're interested in is helping our application code teams understand their performance. So a lot of them are set up to do nightly performance regression testing. So every cycle of time, whether that's every night or every month, they're wanting to run their tests that they're interested in, see what the performance is. They also want to understand if this Git commit happened, how did that change my performance? And also, how do changing parameters affect the different performance that they're seeing? We hope to integrate benchmarking into the lifecycle suite from simulation up through system maintenance. So really working with our vendors, kind of forming this co-design effort so we can really help our vendors inform how they're designing their future memory systems, hardware, et cetera. And then we're also interested in doing performance regression testing of our software when porting to new systems and platforms. So this goes back to what Nate was saying. We want to be working closer with the HPSF communities, looking at Cocos, maybe Chapel as well, but all these kind of different portability models so that we can really get the most performance out of our systems. So how Livermore has tackled this problem is with a harness called Benchmark, and we've really pushed to encode a lot of these definitions and specifications into our GitHub repository. So everything is open source. We rely on SPAC for understanding how to build our benchmarks in a reproducible way. We also rely on Ramble, which is an open source project out of Google Cloud. It's kind of while SPAC is to defining how we build packages, Ramble is to define how we can run our experiments for our applications. Also included in Benchmark, we've got our specification for different systems across many of the labs that are sitting up here with me and facilities. So we really can define our software stacks that we care about. We can plug in different MPI versions of different software packages. So you can really change how the system is defined so that you can build your benchmarks in a reproducible way. And we've also specified different experiments for the different applications as well. So the Benchmark project is really leveraging different advances in HPC automation. So we've got GitHub for code, and we've got our build specifications through SPAC, our run specifications through the Ramble project, and then we're also running this through CI and C-, so you can kind of see where we're testing the different benchmarks. And so Benchmark's really designed to be run reproducibly across our sites and across different systems and even iterations within the same system. And we've really encoded all of this information into Benchmark up on GitHub. So you can repeat runs from the same user, maybe by a different user. We can replicate different runs across different systems and be able to reproduce without this kind of manual process that we've all experienced where I send you a script and you try to iterate and you say that didn't work and you give me versions, et cetera. We're really trying to remove that step in the loop. One last plug, since I'm coming from the performance analysis side, kind of the last stage that we've plugged into Benchmark is this Benchmark analyze command. So once you've run your benchmarks, collected performance data, you can actually run this benchmark analyze command, which leverages our caliper and thicket tool suite that we've developed to be able to programmatically generate these performance analysis graphs. You can also get the call tree, which is on the far right, but you can kind of just quickly be able to run through the full benchmark kind of pipeline to be able to run your benchmark, collect performance data, and do the analysis at the end and put that into reports and milestones, et cetera. Thank you.
Okay, great, thanks, Stephanie. Okay, it's time for our panel. I have some seed questions here. These are extra spicy, so we'll start off, and then folks can come up to the microphone and ask questions as well. And comment too, so I'll also get comment from anybody in the audience as well, feel free. Okay, so I'll start out with our first one. How do you differentiate between continuous integration testing and benchmarking from a user's perspective versus from a system software perspective? For example, when you're changing different layers of the stack, maybe when you're developing your code, you want to check that your code is correct, but maybe you also want to check that your code is correct with a particular compiler. And how do you make sure that you're running it the same way that a user would run it versus the way that you need to lock it down for development? So if anybody wants to take that.
Okay, I guess I'll get started. So CI, probably you'll want to be a little bit more extensive in terms of the coverage you'll try to achieve. Like you really want to stress different combinations of compilers, tool chains, the options you can use, for example, with CMake to configure your software. And you're trying to make sure that what you're doing your best due diligence to not break the develop branch or whatever, so that others can keep on, making work and, progress as we go along. I think in terms of performance, historically, while it is important, it's been viewed as slightly less critical. You'll find probably less projects doing it, so I would say you typically do it across less variety of architectures. And one of the challenges, especially for large math libraries that I've seen, is like, how do you get enough of a slice of a system to do something meaningful? If you run on a single node, you're not stressing MPI. If you run multiple nodes, a couple nodes is nice, but when I studied at Sandia, I worked on multi-grid. Sometime down the grid hierarchy, there is something that becomes empty, but I need enough levels to get that, so I need enough nodes, yada, yada, yada. So there is a definite different challenge when you're going to go for performance monitoring, benchmarking, and unit testing. And I think it's a hierarchy of concerns where you need more resources to address, and it also probably kind of gives you an idea of the frequency at which you might want to run these different levels of testing.
Okay, that's really interesting, thanks. Yeah, like in other words, you, coming from a system software perspective, when we update things on the system like system administrators, that might be a great time when we have a chance to run some of these things at scale. So if you're hitting correctness bugs at scale, that would be a great way to test. Anyone else? Yeah, go.
So on Chapel's side, I can say that we have different kinds of performance testing that we run nightly, and one of those is basically literally running user applications directly. As I mentioned in the opening, our testing system can be really powerful because it's really custom made, so it allows us to literally git clone a repo and then run something on that repo, and use that to nightly test our user applications in the way that users use them. So this is something that we do on one side, but at the same time, those applications are thousands of lines of code. If there's a regression, it's really hard to find out what's going on. So in many cases, specific regressions are caught by more micro benchmark type things that we wrote that are also pretty esoteric to Chapel, maybe stuff that user won't ever write. But I think those two, having micro benchmarks that are 15 lines of code that are testing very specific feature of the compiler versus thousands of lines of code that is written by the user, I think that's kind of dichotomy helps us a little bit so that we can run the user application in the way that user intends to, while still running the micro benchmarks in a really esoteric way that can help the compiler and the runtime developer. So I think that's the strategy that kind of helps. It's not a perfect solution though.
Okay, Cool. Anyone else have any takes on this one?
Well, I kind of feel like we shouldn't be trying to make such a big difference. I mean, we kind of like CI has kind of become the norm now, like everyone does correctness testing, but I think like we should be encouraging people to do performance benchmarking on the same kind of level when you're developing applications. When you're changing your code, you should be aware of like what are the performance implications of the things you've done, not just the correctness. But yeah, like you mentioned, like having a platform to test performance is sometimes difficult.
Do you have a comment? Yeah.
Not a comment, but like a question. If you,
Sure. Yeah, go
you
for
guys
it.
are done with this one. All right. Maybe this is like some sort of a sensitive topic, but now like the chip manufacturers are more kind of interested in like AI factories and like huge projects. So I mean, in my experience, sometimes like showing them a certain amount of benchmarks that they need to kind of go through, and they just respond with, oh no, this is like too many tests. So how do you kind of convey the information that, no, these are actually tests that we need to kind of be like, to kind of see run, and not the fact that we're just like being greedy and we want like so many things to be tested, so.
Yeah, so I'm, working as currently I'm the lead on, benchmarking for Ultra Ethernet Consortium for HPC benchmarks specifically, and I'm running into this exact, point, which is I don't want to overburden vendors with too many benchmarks. We don't want to throw all of them at them. I've had in that context, I've had a variety of different, quite interesting responses. Some vendors want to run everything. They're happy to just run, just give me, they're saying, of course, they're coming from the AI ML space. They're saying, give me a container, and I want to run everything you got. And I'm saying, well, actually, I don't know if you really want to get into that. So I think it's always important to think about what hardware they're making. So in that case, they're doing networks. So I focused more on my, critical micro benchmarks that mirror our communications patterns that we really need. So instead of saying, we do care about all reduce at, medium message sizes and small message sizes, right, which they weren't testing for AI. So there's some things like that. But yeah, we have to, it's a constant challenge of how do you pare down. You don't necessarily want to throw everything at a vendor. But also it can help to have a nice framework so that they can just run everything and then hand you the output and you can say, okay, this all looks great, but that looks really bad. So yeah, anyone else from the panel have any comment on that, or? Okay, well, yeah, go ahead, yeah.
Well, I mean, that's definitely been our thinking as well, that if we have a nice framework, we can give to a vendor and say, like, here's a suite of benchmarks, run them and tell them, give us the data, then that makes it easier for everyone.
Yep, absolutely. Go ahead, we'll take a question.
So one of the things that has come up over the years as part of the system acceptance is issues with compilers. And so I haven't seen much of a discussion about compilers in the course of this discussion about benchmarking. And so for the Sierra system at Livermore, one of the things that came up was that the dwarf information that was produced by IBM's compiler was nonsense. And we had written a test using some templated functions, and you couldn't identify the n squared loop or the n cubed loop that was in this. And so I think that if the goal is to support application performance analysis as well, I think that there should be some testing of the compilers perhaps as part of the benchmarking suite to just make sure that they're putting out sensible information. And so a couple more comments about that. So for the OpenMP tools interface, I've seen some regressions over the years as different versions have come out. There's issues with line mapping information where optimization in LLVM, conveniently, if lines of code get optimized, then they map the performance back to line 0 because they don't want to be inaccurate. So like, you have common sub-expression elimination that combines things in line 9 and line 22, and then they map it to line 0. And so I think that a little bit of attention to the kind of information that the compilers are reporting in terms of their mapping can be helpful in terms of making sure that we end up with a solution where out of the benchmarking effort, we end up with performance that can be mapped to application code so that it supports application performance analysis at the end.
Yeah, that's a great question, great point too. Anyone have any, before I might, yeah, go for it.
So we're doing a lot of this application-related performance analysis, especially, let's say, with the Trinos framework. We have multiple institutional users at Sandia and external users, and they report the behaviors they see on various platforms at Livermore, at Los Alamos, at Sandia, at Oak Ridge, etc. And so we have, like, this is the first layer for us to, like, be integrated with the application, is to, when they report something to us, try to have something that reproduces their concern, add it to our suite of benchmarks, make it run. So we typically run nightly for the performance, because again, in PR it would be just a bit too complicated. And then we try to cover as much as we can variety of compilers options, etc. And so we're not quite at the level that you're describing, but already trying to have, across platform comparisons that gives us an insight into whether this is really the application, because it will be more or less common, like it's the same checkout from the repository, so we know that's a constant. And then we know the tool chains, the third-party library like MPI, maybe we use the vendor blast and other stuff. So these are the variables, and by going across multiple systems, we do our best due diligence to de-entangle these variables and be able to tell you, oh, we have 2 CPU builds only, this one has OpenMP, this one has threads, 2 threads or something, and we do see this variation. These are the compilers, and then eventually you do have to manually drill down because the coverage can't be fully extensive, sorry. But this is how we try to tackle some of these issues. And one of the things that goes with it is how much value you can get out of your benchmark. And so if it highlights where the pain points might be while not giving you the full information, we think it's already good enough value for us, because it launches us into that journey of discovery, if you will, of like, well, is this us, is this the compiler, is this the tool chain, or the libraries?
Anyone else have anything?
So through Benchmark, we also have, like, the systems is encoded, right? So you can define all the software compilers, for example, that you want to sweep over, and then we are able to run the benchmarks across those different software stack, right? And so you're getting then the performance output from there. Again, you'd have to do this manual drill down once you kind of see, as you sweep over different compiler versions, different software stacks. But you'd be able to start to understand why is the performance changing, or at least be able to see it from just changing one simple line in our system specification for that.
Okay, and I see another question. I'll go for it.
Hello. I'm a developer for a distributed benchmarking suite, so for a distributed workflow. And something that I've encountered when I'm trying to put in a new feature, or if I'm trying to consider, I don't know, something in the field, I try to focus on the AI part, infrastructure, workflows, anything of that sort. It's rapidly evolving. And it is challenging, I guess, from my developer perspective on organizing my efforts to push out code that's meaningful, that's clean, that's well modular. So I was just wondering, in this community, and from your guys' experiences, how do you face that? How do you work on your style of trying to develop your benchmarks? Do you encounter these sorts of challenges too? I just want to hear perspectives.
Well, first of all, kudos for what you're doing with distributed workflow benchmarking, because that is not easy.
Yeah.
Yeah, it's one of the things that we have to work on in our own, framework with Benchmark is we're talking about developer workflows to try to make it a fast path for you to quickly iterate over whatever features you're adding. And so, SPAC can help with that, to a degree because you get so much control with your package PI files and stuff like that. But yeah, it's a challenge because then once we go into a larger benchmarking framework that's designed to sweep across parameters, things kind of can become increasingly encoded. So it's a tough problem. I'd say from a developer perspective, I usually focus on, looking at what's already out there and trying to extend. If somebody has a micro benchmark or something that you can just kind of grab and use, I'm thinking like for your type of thing, maybe like iPerf3 out of ESNet, if you're doing like wide area networking benchmarking and stuff like that, and then just see if you can plug into their API and just use it, as much as possible.
What if you want to like make it more general though? Because sometimes I find, right, that as the AI sphere evolves and services come up, infrastructure, things like that, they get really, really specific. And so then what I've noticed when I'm working on that is, I want to make sure that I have that general premise covered of like what that service is providing, and there's competitors I know, but then it's like, well, I mean, I gotta start somewhere, so I can't go general first, right? It's like I need to try out whatever this thing is trying to do. So any comments on that?
I usually do like crawl, walk, run. I'll just do like a hello world example, like the simplest possible example in somebody's framework, and then just see. And then don't be afraid to just drop it if it's too annoying or complex, right? And come back to it later is what I usually do. But I don't know if that's the best way to approach these things. But yeah, I start with a dirt simple example.
Yeah.
Yep. Cool. Anyone else?
You want this one?
So as a cloud provider, AWS, I mean, we have that challenge where we've got a ton of services and we've got a ton of partners that bring in different architectures and products that customers are constantly asking, how does it compare? There's no great answer there. And we've contributed to projects like Benchmark and it's in the hopes that we can work together as part of the HPSF to define what that good looks like. But I do think you're calling out a really good shortcoming in what we've got today, and that's most of the frameworks, most of the solutions that we have for benchmarking they assume static hardware. They assume that the infrastructure is constant and you can just sort of work in that space, and that's not true anymore.
Yes. Yeah, definitely. No, I get what you're saying.
Yeah, it's definitely a tough problem. Yeah, we assume static hardware and sometimes even static software stacks as well. Yeah, it's important to expand. There you go. Push hard. There you go. Okay.
Cool. Okay. So I wanted to be able to use this because I have a question in here. I'm Christy. I'm from Lawrence Livermore. I had a question about should application teams do benchmarking as part of their CI? And then if yes, what should they do with the results? Storage, analysis, all of the above. So.
I know you have opinions on this. I'm the man now.
Okay, I get started very quickly. Yes. Be strategic. It's, in my opinion, the space is very large. You could do many things, go on many platforms. So look at what's valuable for yourself. If you're an application developer, look at what your customers are facing, like what are the really critical things, at least as a very first step, going toward generalization and managing your resources. Ideally, you would want to use frameworks that are fairly well used by others so that you can leverage this community knowledge. It gets you started faster versus if you develop your own solution or come with like an arcane, bespoke, benchmarking framework that is, maybe less documented, etc. And then I think in terms of sharing, we are all hoping that we can host things that is then accessible by our stakeholders. So that'd be usually, maybe my manager who said like, we really need to make that software portable and performant, or it might be my, my users who really want to, verify before they get the next release that, oh, yeah, it didn't regress, or the performance is improving, or is good on that platform. Or it might be other people in the community who want to do not performance monitoring, but benchmarking. By having the data public, we can quote unquote measure ourselves up to the same, stick, and then, get an idea of where we are at and how to make progress and etc. That's my 2 cents, I guess.
Yeah, I would echo a lot of the same thoughts, right? I think we're getting these questions about how do application, what's a set of parameters that's useful to the application team, right? And so if you guys have that in your CI, if you're publishing this to a dashboard, we can, as the community, can kind of see how is it that you're running it, what kind of knobs are you playing with to explore the performance. I think there's also this concern that we have, right, of what is appropriate for CI versus what's appropriate for benchmarking, right? And I think when we talk about benchmarking for performance, you need resources, which tends to be where we're most constrained, right? I think you could come up with, an infinite number of experiments to run for your application that would test different aspects of your code, but then we have to be concerned with how, what is the hardware and what's the system that you're running on to support that. But I think as a community, being able to publish and share and have this widely available of how you run it, what the performance looks like on the systems that you're interested in, I think would only benefit the community from having to go back, rerun it, myself, so that I can, confirm, or I didn't see results for a given machine and I want to test it. I think that's all really useful to have in the community.
So your question had 2 parts. I think the first part is definitely yes, from a systems perspective, because we are testing application code, and if there's a commit upstream in the application that has performance regression, we report back to the application developers. It's kind of roundabout and inefficient, but we have more resources that we can do benchmarking, so it's kind of understandable too. For the second part, I think it's all application dependent. I think my yes, strong yes for the first part is more about regression and CI as part of performance testing perspective. Whether you have long-term aspirations to keep track of your performance over time, I think it's very application dependent, from my perspective at least.
Cool.
Thanks.
Yep, thank you.
Hi, I'm Andy Warner from HPE, and we've had, there's a shameless plug here, right? We've had a lot of talk about compiled tests, MPI tests, classic HPC stuff. I want to, one gap that a few of us have identified is, none of these tests are particularly relevant to the Python community, right? So I want to plug a very young project that's open source. It's out on GitHub called Torchhammer. And for a very young project, it's already got 9 tests. They're synthetic tests, but there's also real world, real codes like heat transfer, shit like that. It's single node. It came from our field organization, so it's really designed to do stuff like test a node's behavior. But as we've used it and word has spread about it, people are now using it to do things like, well, I'm actually going to use this to validate my PyTorch installations that I provide to my users. If I provide a canned PyTorch, I'm going to use it for that. So it's designed, so anyway, I won't blab on too much about it, but it opens, for us, it opens up a whole new front. This came from the field. It does stuff like pulse telemetry, like it'll report the temperatures of the GPUs, so you can spot when your cooling loops are misbehaving or when your TIMs are drying out and stuff like that. So it's very good. But for us, it opened up a whole new aspect. It was not just the classic, build some code, compile it, run it with MPI, blah, blah, blah. This is easily containerized, self-contained, it takes a licking and keeps on ticking. It also supports multiple data types. like 6 data types out of the box, which I'm not aware of many C or Fortran programs doing. You just have to build different variants of them. So I just want to plug it because for me, it was eye-opening, because when I worked with the people that were doing it, they suddenly were pushing in a different direction. Instead of bashing our head against the same brick wall, it was like, no, this is a new direction to go in, and that to me was pretty compelling. So I'm a big fan of Reframe and of Ramble and Spec, as people will know from me. So it doesn't obviate any of that. It's just another component that can drop in. And I wanted to plug it because I think it's good. I think it's worth it. It's already open source, and I welcome contributors.
Cool.
So.
Yeah, thanks. It's nice to hear about vendors opening source on some of these different types of stress tests. Cool. Okay, so I have more questions. We have some more time, so I'll ask more seed questions unless folks want to come up and pepper us with more stuff from the audience. So one of the things I was wondering about is how folks are handling, I'll just pick one at random, post-testing analysis of your results. You know, how many frameworks kind of support this? How do you support it? You know, do you print out charts or put stuff out on, you know, some database? I know a lot of folks are talking about different databases for performance data, but what do people do?
So on Chapel side, we have performance plots that are also, surprise, surprise, very bespoke to our testing, but those plots are publicly available. So basically what they are is just the x-axis is time, and every day you get a new data point, and y-axis is performance or time. But I think none of this is super interesting. One cool thing that we have in the suite is the idea of annotations. So what we can do as developers is when we notice a regression or a nice surprise, a performance bump, we can annotate it. So when we look at it like 2 years after, we can just see why, like which PR resulted in that kind of performance change, and that can give us some perspective. In terms of data storage, the story is not that great there. We just version control our tables, which are literally just tables, like space-separated tables that you can just, like dot files. Obviously, a database would be ideal, but then again, there's a cost to refactor our infrastructure. So, yeah.
Yeah, I'll go quick then. First, we love what the Chapel guys did, so we stole it. So we do annotate, you know, we plot stuff, you know, every day we have a new point that comes on the chart, and when we see it, you know, drop down, we're happy, but we still dig into like, why did it drop down? Like, what did we do well that we can replicate maybe? When it goes up, it's the other way around. It's the fire drill. We try to figure out what happened and how to bring it back to the normal level. And so, but the process is currently eminently manual, where we need people who understand the code and where it runs to look at these charts and figure out, okay, where do I need to drill down in my code base to to find? And so, what the problem is, of course, we have Git commits that gives us an interval of changes that we can look at and hopefully captures the problem. We also have information about the system, so we can check if yesterday and today the system had an update, etc. But I think one of the difficulties in the post-processing is really finding this extra value step where our post-processing starts to hint at what might have happened without asking someone to spend at least probably an hour to even get an idea of where things might have gone wrong or well.
Yeah, I mean, one thing we realized was that like the post-processing step has to be reproducible as well. I mean, it's very easy to like generate plots, but then like you need to be able to like compare things in a reproducible way, and so the post-processing sort of has to be has to have an API that you can sort of write, like you can write code for your post-processing and keep repeating the same things, and you can hand it over to someone else and they can check your result, get the same results as you did. I don't know. I don't have a great solution for that. We wrote a library, but I'm not super happy with it.
Yeah, that's a common story. Okay, you have a question from the audience?
Yeah. I am Mike Huru. I don't think you mentioned this, but another role I've seen for benchmarking emerging is in the training of AI agents and tools, to know that they're generating not only correct code, but, and workflows. It's not just code, it's actually workflows too, right? But workflows and code that perform well. Have you considered that as part of the scope of the benchmarking efforts in this conversation? And would it fit?
We have not really looked at that. One of the things, of course, that becomes a challenge when checking correctness for AI code, AI-generated code, I always recommend a human in the loop. There was research conducted actually at my alma mater, UC Davis, where, and folks can read it if they're interested, from Professor Matt Bishop, where this was for cybersecurity, but finding vulnerabilities in code in an automated way generally reduces to the halting problem. And he had a whole proof of it via Rice's theorem, et cetera. So I think it's probably for correctness. We're probably going to want a human in the loop for the foreseeable future. But for performance, yeah, that's very interesting, because if you are using, AI-generated code for performance, I think that's a huge area that we haven't really looked into, because it is, possible to get, large parameter sweeps and let an AI just figure out, for my field in MPI communications, maybe the eager versus rendezvous point, what message size you want to do that at, and figuring out tuning parameters and auto-tuning. It's been, something we used to do with ARIMA and regressions, but it's kind of interesting now that you could probably just throw it in an LLM and just say, hey, figure this out for me. And if it's better than what you did yourself, then you look at it and say, oh, that might be the right parameter to set. Anyone else have comments on this? Or an interesting point, though. Yeah, thanks. Yeah.
I think you can. You immediately want to do that, Mike. I agree. Like, you can think of it as, the AI playing a video game or a board game or something. Like, it's a nice, interesting problem, because there is some form of easily observable success. Like, are you actually so obviously you have the correctness aspect, but then is it just simply running faster? And you can help, train your AI automatically by saying, like, oh yeah, this was positive, this was negative reward, and move forward. I think the main thing in this context is to have, like, really robust frameworks that are flexible enough that you can let the AI play and, use it as a sandbox to make progress. And I think that's probably one of the directions where it's a little bit more difficult. Like, we deploy these things manually a lot of the time, because our machines are not always very simple to, dial in just right in terms of, like, how you build the flags, the environment parameters, etc. So that would be something where I can see it trip itself easily.
Okay, I have another question from the audience. Go ahead.
Yeah, another AI question. I'm no expert, so definitely check my correctness on this. But I have the impression in the AI community there's a lot of action on, I guess they call them control planes, but they're tools for tracking experiment configuration and results and checking quality. And it sounds exactly like the sort of thing a benchmark tool would want to store. And I'm wondering if it makes sense to be using that sort of a tool for storing benchmark results and storing them, keeping track, as opposed to developing yet another one ourselves.
Yeah, it's a good question. I think that definitely it emphasizes that we should be looking at standard APIs for, storing benchmark outputs and things of that nature, so that it can be more easily interacted with AIs. Yeah, that's a good point, and I think it's probably something we should look into as far as automating a lot of this sort of work.
I have the impression there's no standard in that community either. So.
Right. Yeah. So it'd be, this would probably be a great opportunity for us to push on one. Yeah. Thanks.
One thing we try to explore is just automating performance regression detection. As I mentioned, we have plots that are nightly generated, and right now a human has to look at those hundreds of plots until their eyes bleed to see regressions. But if you can, like, statistically tell that there's something that is beyond noise, that would be beneficial. But what we explored there has been only in statistical realm, and we ended up feeling a little bit old school about it. Like, we want to see it on our own eyes and make the decision as humans as this is a regression versus this is noise. So it's kind of relevant to what you're saying, but yeah.
Okay, and we are, does anyone have anything else they want to? Okay, we are at the top of the hour, so I will just put some of our links for the benchmarking working group. You can join our working group Zoom meetings and our Slack channel here with HPSF, and we can continue this conversation both here over coffee and then also in our working groups. So we're very excited to continue working with HPSF, and and let's thank our wonderful panelists as well for being impeccable.